Hi guys, welcome to lesson 12.8, Probability of Compound Events, your final set of notes for Algebra 1. Our objectives for this final lesson are that I can find the probabilities of mutually exclusive and overlapping events, and I can find the probabilities of independent and dependent events. Alright, so problem 1 is mutually exclusive and overlapping events. A compound event is made up of two or more events linked by the word and or the word or. Mutually exclusive events are two events that have no outcomes in common. This would be your or. Overlapping events tend to have at least one outcome in common. You're most likely going to see an and on this one. Okay, so the way we deal with this, to the mutually exclusive events, we add the probability of one event plus the probability of the other. For overlapping events, we're going to do that same first part. We're going to add the probability of one and the probability of the other, but then we are going to subtract our overlaps. So for letter A, we've got, suppose you spin a spinner that has 20 equal size sections numbered 1 through 20. What is the probability that you spin a 2 or a 5? These are mutually exclusive. There are no overlaps between 2 and 5. So you have a 1 in 20 chance of getting a 2. And you have a 1 in 20 chance of getting a 5. So you add them together, which is 2/20ths, which reduces to 1/10. So you have a 1 in 10 chance that you're going to get one of the two numbers that you're looking for. All right, so now letter B, what is the probability that you spin a number that is a multiple of 2 or 5? So let's just start out by listing our multiples of 2. We have 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. Our multiples of 5 are 5, 10, 15, and 20. Now you can see we have overlaps here. We've got overlaps. The 10s overlap and the 20 overlaps. So what is the probability we're going to get a multiple of 2? There are 10 options there, so it is 10 out of 20. And we're going to add the 4 out of 20 possibility of getting a multiple of 5. And we need to subtract our overlaps, which are 10 and 20. So that's 2 of our 20 possibilities. So we get 12 over 20, which reduces to 3/5. Okay. Letter C. Suppose you roll a standard 6-sided dice. What is the probability that you roll an even number or a number less than 4? So let's just list out our possibilities. An even number on the dice would be 2, 4, and 6. A number less than 4 would be 1, 2, or 3. So probability of an even is 3 out of 6, plus there are 3 out of 6 that are less than 4. And we are going to subtract our overlaps, which is 1 out of the 6. And so you're going to get 5/6. Letter D. What is the probability that you roll a 2 or an odd number? So we've got a 2 and we've got a 1, 3, and 5. So we've got 1/6 plus 3/6, which is going to equal 4/6 or 2/3. You should reduce these fractions if you can. Okay. Problem 2, we are looking at independent events. When one occurrence of an event does not affect the probability of the second. So you're talking about two separate things, two separate dice, two separate spinners, something like that. In this case, you take the probability of one and you multiply it by the probability of the other. So we roll a red dice and a blue dice. What is the probability that you roll a 5 on the red dice and a 1 or a 2 on the blue dice? So for the red, there is 1 out of 6 chances that's going to give you the number you want. And for the blue dice, there are 2 out of the 6 possibles that are ideal. So 1/6 times 2/6 2/32, 36, which is equal to 1/18. Okay. Suppose you roll a dice and flip a coin. What is the probability of rolling a number greater than 2 and flipping heads? Okay, so we've got 3, 4, 5, and 6 are our 3 possibilities that are greater than 2, 3, 4, 5, and 6. And on a coin, you've got heads or tails, so it's 1 out of 2. So when we reduce that, we've got 2/3 times 1/2, which is 2/6 or 1/3. Again, make sure you reduce. All right. Problem 3, we are selecting a tile at random with replacement, which means when we pull a tile out, we are going to replace that tile back into our pile of ones that we could choose from. So our probability is always going to be the same of the number of tiles you're choosing from. So we're choosing a random. We've got, we want to know what is the probability of getting a dotted tile and then a dragon tile. So the dotted tiles, there are 1, 2, 3, 4 dotted tiles out of 15 total. And we are multiplying by the probability of getting a dragon, 1, 2, 3. There are 3 dragon tiles. And when you get that, four 75ths. Ms. Zurzo used her Chapter 11 simplifying skills to, that was a 7.
It looked like a 2.
All right then. What is the probability that you choose a bird and then after replacing the first tile, a flower? So the bird, there is 2 birds up there. 2 out of 15. And then the flower, there is only 1 flower. So 1 out of 15. So you multiply that out, you get 2 over 225. Can't reduce that. Okay, so with replacement, we will always have the same number of possible tiles to be choosing from, as opposed to selecting without replacement, which means we are these are dependent events where the outcome of one depends on what happens in the first outcome. So suppose you choose a tile without replacing. What is the probability that you chose a dotted tile and then a dragon tile? So there are 4 dotted tiles, but now when we go to pick our second one of those tiles is gone. So we're going to cross out one of those dotted tiles. Cross it out. All right, that tile's gone. So now there are only 14 tiles left that you can choose from. We're trying to find a dragon tile, so we've got 1, 2, 3 dragons. So simplify, use those Chapter 11 skills, or you just type it into a calculator and you get 2/35.
I was too lazy to multiply 15 times 14.
Yeah, I agree. I don't blame you. All right, letter B, what is the probability that you will choose a flower and then without replacement a bird? So in the first case, we've got 15 possible choices and we can get 1 flower, flower then bird. All right, and in our second one, we only have 14 possible tiles because that flower is gone. We've got 2 birds left. It can be reduced. It's reduced to 1 over 105. Okay. There you go. With and without replacement. Fun stuff, right? Last one, finding the probability of a compound event. So now we just have our story. We've got 1 freshman, 2 sophomores, 4 juniors, and 5 seniors receiving top score in an essay contest. 2 students will be chosen from a hat to read their essay. What is the probability that a junior and then a senior are chosen? So, first up, we've got our juniors. There are a total of 12 students in this pool, and there are 4 juniors, so there's a 4 in 12 chance that you're going to get a junior out of that bag. Then that first person is out. Now we have a 5 in 11 chance that you're going to pull a senior. When you multiply it out and reduce it, it is...
Oh, come on, I don't want to do 12 times 11.
I would have just written 5/33.
I can't even work a calculator. Okay.
Okay, letter B. What is the probability that a senior and then a junior are chosen? So we've got 5 seniors, and we've got 4 juniors, which is going to equal, drum roll please, 5/33. So, do these compound events necessarily, are they going to have the same probabilities? Most likely, yeah. If your numerators and denominators are the same, doesn't matter which one comes first, you're going to get the same probability in the end. That is all of our notes. You are now done taking the Algebra 1 notes. So we will get you ready for the final shortly. I know, and it's our last video. It's sad. We hope you enjoyed.